Thank you very much. We're always hostages to technology whenever we do presentations. So we're talking today about code art and embroidery. And this actually links. Is this going to work? Oh, no. Okay.
Wow,
that's intense. Yes, let's not do that. Okay. Right. This came about because the city we live in was UK City of Culture 2021. And in order to celebrate that, there was a celebration looking into the past and some of the significant things that were done in the past, but also looking forward to where Coventry would go in the future. So it wasn't just a sort of retrospective. So that was the symbol. Coventry is well known for its beautiful ribbons. For the last couple of hundred years, it was weaving beautiful ribbons. And you can see the jacquard loom there. And what I didn't realise until quite recently is that's a modified jacquard loom. It does 8 ribbons at the same time. So it's a bit more complicated than the normal jacquard loom. Coventry is also home to two-tone music. I don't know if anybody knows about it, but it started in Coventry because there was a lot of immigration in the 40s and 50s, 30s, 40s and 50s, and there was a fusion of the music, and it kind of exploded in the 1980s. So that's a little bit of the history of the background to what I set out to do. I came across Clive Richards' work. He worked at the Faculty of Art and Design at what became Coventry Polytechnic and then Coventry University. Polytechnics at that time were at the fore of applying computers in industry. Universities in the UK were focused probably a bit more on theoretical research and on the computing discipline itself. So a lot of the polytechnics were busily using computers to do computer-aided design, to do fabric design, and to apply it and feed that into industry, if you like, to give computer-controlled equipment. Coventry had a strong background in art and design, and that's where Clive Richards worked. Somehow, in 1973, he was fortunate enough to find a line plotter. So a line plotter in 1973 was very unusual. So he started creating these series of works, and these are in actually the V&A Victoria and Albert Museum in London. And Clive came and spoke to us for Coventry City of Culture, and I just thought it would be really nice to recreate his work. So that's what I set out to do. That's his 100 cubes, and this is 361 cubes. I didn't have the maths to do this by myself. I'm a computer scientist. But Robert, my husband, fortunately, is a bit more of an expert mathematician. You were a reader in maths compared to me. So if I move on one. Right. So Robert is going to describe some of the maths concepts we used to complete this.
So at this point, I became a sort of advanced model of GPT with the advantage that you could tell him what was wrong and get him to fix it. So the first thing we have is the problem of how do you stitch one of these cubes? And there's a snag here because what you would ideally like to do is go over each of the edges just once. But those of us who remember our primary school or secondary school puzzles will realise you can't do that. I invite you to try. You can pass as much time as you like. You will not manage, but you can sneakily trick it. Instead of trying to go over each edge once, the reason you can't do it is because there are too many corners with an odd number of edges coming into them. You can only go over each edge once if there's either no odd corners or just 2 of them. How do you fix that? You go over each edge twice, and all those 3 edge nodes become 6 edge nodes. And then you can go over the whole thing twice, and that's what you want, because you don't want to be making lots of jumps in your stitching, and you don't want some edges gone over twice and some gone over once, because then they'll look wrong, some thicker than others. And then, of course, you've got the other problem that inside your computer model, you've got a cube, which has got 3 dimensions, and you don't have 3 dimensions of fabric to stitch it on, you have 2. So you do the sneaky thing of just looking straight down on it, so to speak. You ignore the Z coordinate and just join up the XY coordinates of these points. And that solves the problem with the slight detail that you have to know just which cubes you have to draw. Well, those of us who did secondary school mathematics, depending on where they live, will recognize this matrix here is what you need to do a rotation in the xy plane by an angle of theta, and either clockwise or counterclockwise, depending on whether you're a mathematician or a computer scientist, because computer scientists use a left-handed coordinate system. They're all mad, or perhaps I should say you're all mad. The mathematicians, me, possibly Brian, we're the sane ones. But this will move things around in the plane, but we don't want to do that. We want to move them. Oh, does the mouse not show up on the screen there? Ah, sorry. We want to move them around in 3 dimensions. So the first thing we want is a way of rotating things around as you look straight down on them, looking along the z-axis. And we just do that by not changing the z-coordinate, but changing the x and y. Oh, you do get an electric shock. By moving things around in the xy plane. We need to move them around on the other axis, but we just use the same matrix, basically. But instead of keeping z fixed, we keep x fixed. Now, what we do is we make theta equal to 10 degrees because we want to have 10 cubes going along the way, a rotation by nothing, then 10, then 20, up to 90, which takes the cube back to where it was, gives us a row of 10. So that theta becomes 10 degrees. Now then we've got to, I say stitch them together. We've got to fit all these pieces together. So we start off with the cube in what you might think of as a natural position, just sitting there at the origin of the coordinate system. And then we construct that. It took me about an afternoon to reconstruct how we'd done this, looking at the output and looking at the matrices, but finally figured it out. If we go back to here, we start off by working out what needs to go in at the bottom of each column. Now, yeah. So we think about the x-axis is going along here, the y-axis is going up the page, and the z-axis pointing straight out towards you. So we rotate about the z-axis by 10 degrees, 20 degrees, 30 degrees, 40 degrees, and so on all the way along. And then for each of these starting points, we rotate about the x-axis. That's the one pointing this way, so it's rotating like this. So this gets rotated by 10 degrees, then another 10, and so on all the way up. So our algorithm, roughly speaking, is start off with a cube, then make each column by rotating the base cube 10 degrees around the z-axis from the previous one, work up the column by stitching the cube, rotating it by 10 degrees about the x-axis, and repeating that till you get to the top. And then you've got some jumps to go from one cube to the next and from one column to the next, but everything's stitched over twice, except when one edge is exactly on top of another, then it's stitched over 4 times, but you want that because you're seeing the edge twice. And that gave us a sort of replication of Clive's work, but done programmatically in Snap. Well, in TurtleStitch, I should say, but Snap ported to TurtleStitch. And that was my bit done. Once that was done, she could sort of switch me off, put me back in the box, and get on with interesting stuff.
Okay. So, anyway, we recreated the designs using embroidery. And if anybody wants to see what the originals look like, I have got them under the chair, but there was nowhere to put them here. I sent them to Clive. Clive was so excited that to see people valuing his work so many years later, that I was able to exhibit this, and he loaned me some of his original work, because he'd got multiple copies of it. He loaned me some of his original work to exhibit alongside, which was very nice to do. So that's it. I hope you followed all the maths.
Missed a bit. The point about the two-tone music was it was some of the very early music that was being done by bands which had black and white musicians in them. Black and white. It's a two-tone stitch.
Yeah. So I deliberately did it with white stitches on black thread and black stitches on white thread. So that's it. Thank you very much for listening. I hope you followed the maths. We're going to test you on it shortly.
It was the easy bit.
Yeah. Okay, thank you.